Lesson 411, Area Models for Rectangles and Rectilinear Figures. The focus in this lesson is for you to find the area of a figure, for you to share strategies for finding area when the perimeter and only one side length are known, and for you to find areas by subdividing rectilinear figures. But first, let's start with our mental math and fluency. Solve the following multiplication or division number stories using the correct unit in each answer. Tanisha has 45 apples. How many bags of 9 apples can she make? Well, hopefully you're realizing that if she has 45 total and they want her to put 9 apples in each bag, you're going to be taking 45 divided by 9, which should give you 5. But 5 what? Because it's actually asking you to do the correct units. She's going to be making 5 bags. This is your units, what they're talking about, the bags. For the next one, it says, donuts come in boxes of 12. How many donuts are in 10 boxes? Well, if I have 12 donuts and I have 10 boxes of those, I'm going to be multiplying to find my answer. So 12 times 10 is 120. But don't forget, it's telling me to put the correct units. So what am I going to have when I get done? I'm going to have 120 donuts. That's what it asks, how many donuts. You're going to have to be careful when reading these problems to make sure that you're understanding what the units are. Were they talking donuts or were they talking boxes? Finding the area. Remember, area is not adding. Area is multiplying. If the perimeter equals 752 and this is 367, how could I find out what the side measurements are? Well, first, I know that my perimeter is 752. That's my total. I would need to subtract 367 because that's the length of this one side. But I also have the top side, which also is worth 367. When I add those two together, 7 plus 7 is 14. I carry the 1. 6 plus 6 is 12. Plus 1 is 13. I carry another 1. 3 plus 3 is 6. Plus 1 is 7. I need to take 752 minus, because this is what it told me to do once I figured this answer out, the 734. Again, I need to borrow the 5. I take away 1. 5 minus 1 is 4. I put the 1 in front of the 2. 12 minus 4 is 8. And 4 minus 3 is 1. So the result was 18. I need to divide that by 2 because I have 2 lines, 2 endpoints. So that means each one of these is 9. That looks a little deceiving there because I drew to show you where that line's at. But it is actually simply 9. So I know this line is 367, this line is 367, and then each of these adjacent lines would be 9. So, work with a partner to finish the Math Masters page 174 and find the area using those numbers that I just gave you. So pause the recording now and please do that for me. Now we're going to find the area of a rectilinear figure. So look at the figure I just drew and the figure that you see here already done for you. How are they different? Well, hopefully you're noticing that one is simply a rectangle and the other one is not. How are they alike? Well, look, they both have right angles and parallel sides. How might we go about finding the area of this shape? I'm hoping that you thought maybe you could break the figure into smaller rectangles and add the areas of each small rectangle to find the area in the upper right-hand corner, and then find the total area of the larger rectangle and subtract the upper right-hand corner piece, and then count the individual squares. This shape is called a rectilinear figure. It is composed of a number of adjacent rectangles. So remember the properties of a rectangle. There need to be 4 sides, and all angles need to be right angles, and there needs to be 2 pairs of parallel sides. When finding the area, it doesn't matter how complex the rectilinear shape is, as long as it can be divided into smaller rectangles or squares. So let's find the area, an equation for this rectangle. This is on Math Journal page 125. I'm going to help you with the first one, and then you're going to do the rectilinear rectangle yourself. So for this equation, you should know that you're going to take 25 times 15. And that's going to give you your area, because we multiply for area. I'm going to do partial products over here to show you again how to work it. So when using partial products, you take 10 times 20, which is 200. Then you take that 10 spot and multiply by the 1 spot, so 10 times 5 is 50. I'm done with the 10 spot, so I go to the ones. 5 times 20 is 100. And then I take 5 times 5, which is 25. Now I know that I've multiplied both numbers with the ones. I add this up, 0, 0, 0, 5, 0, 5, 6, 7, 2 plus 1 is 3. My answer is 375. Here's my units, centimeters. So how many square centimeters do I have? 375. Let's go back and take a look at the previous problem. I chose to do this way so that you get to see the example I'm going to do right before you try to do the problem that they're giving you on that page, because the problem you're going to do on Math Journal page 135 is an assessment check. So this is you're going to have now right before you have to do that assessment check. So one way we can do this is we can look at it and break this into rectangles by drawing a line down here. This would be one rectangle, and this would be your other rectangle. So how would we go about solving this? Well, remember, if I'm breaking this up, no longer is this line considered 10. This line would be 7, because that would be parallel to this line, which also is 7. How am I going to know how long this line is? Well, 7 plus what is 10? Plus 3. So now you know these two lines are parallel to each other, and they are exactly 3. This line and this line are exactly 4, but when comparing it to this line for this rectangle, it would be 6. So first I start out by going 7 times 6. That is my baseline here, multiplied by my height, which gives me 42. So I now know that this rectangle here is 42. Now, when I'm looking at this smaller rectangle, I know that I'm taking 3 times 4, because this is my base here and my height. Which equals 12. So in order to find the square units for this, I would add those together. My triangle is 54 square, I'm going to abbreviate it, units. Now I want you to try to do that with the shape that you have on your math journal page 135. When you complete that entire page, I want you to bring that up to me so I can check it and see what you understood and what you did not. Pause the recording now and finish that page, please. So now for a quick review, let's select 2 fractions that we think would match. So you should be using those fraction cards that you cut out earlier, and you should be writing them here. I'm going to write 1/5 and 2/10 because those are 2 that I know match. How do I know they're equivalent fractions? Well, I like to use the multiplication method because to me that's the easiest one. I know that whatever I do to the denominator, if I also do it to the numerator, they should be equal when I get done multiplying. So how did 5 become 10? I multiplied it by 2. Notice I wrote by 2 here, so I'd write times 2 here also. What is 1 times 2? 2. So 1/5 equals 2/10. And this is my proof to prove it. Your next assignment is going to be Math Journal page 136. Read this to yourself silently as I read it aloud. It says, the Cupcake Store earned $1,254 on Wednesday, $2,902 on Thursday, and $2,877 on Friday. On Sunday, the owner counted all her money, showing that she had earned $10,502 for 4 days. Well, how much did she make on Saturday? I'm going to help you set this up, and then I want you to do the rest of the work. So we know the total was $10,502. That has to be what it says she made for a total. Next, what you're going to do is you're going to subtract what she made on the other 3 days. So she made 1,254 plus what she made on Thursday, 2,902 plus what she made on Friday, which was 2,877. Once you figure out that answer, you need to subtract it from your original $10,052 to get your final answer for how much money she made on Saturday. Again, this is Math Journal page 136. Pause the recording now. When you are finished with it, I need you to go back to the answer key to correct that entire page. Any that you got wrong, please bring it up to me and I will show you where you were not thinking correctly. The final thing you're going to do for this lesson is Math Masters page 176. Don't forget, if you don't have that now, it's up in your file folder. You are going to be looking at finding the area. So first you need to write the equation and then your answer. Complete this entire page, bring it up to me, and I'll help you finish it if you got anything wrong. For the more difficult problem down on the bottom, don't forget you got to cut it into rectangles first in order to find that area, and you're going to have to show me how you did that. If you're struggling with this, again, bring it to myself, Mrs. Voorhees or Mrs. Wolfcool, and we will help you. Thank you. This is the end of 411.